Hi, welcome to video 4.1b, more on integration and an introduction to trig integrals. Okay, so this is very similar to when we took derivatives. This time it's an antiderivative, but it's the same idea. You're going to rewrite this as 7x to the negative 3. You're going to rewrite this as 5 halves x to the negative 1/3. Okay? One of the properties that we have is that we can break up sums and differences. So we can take 3 times, and you can pull out products. So it's basically the integral of 3x squared dx minus the integral of this one dx plus the integral of that one dx. So you can pull the 3 out front just like you can with differentiation. Now remember, we're integrating x squared. It's not 2x. That would be the derivative. We're taking the antiderivative. Remember, we're adding 1 to the exponent and then writing that over the new exponent. So this becomes x cubed over 3. Here's minus 7. If you add 1 to negative 3, you will get negative 2. So you get 7x to the negative 2 over negative 2. Here's your 5 halves you've pulled out, and you're integrating x to the negative 1/3. If you add 1 to negative 1/3, you get 2/3. Now, that's going to be x to the 2/3 over 2/3. I'm going to start skipping that step and immediately writing that as times 3 halves. After that, it's just simplification. X cubed. These two negatives will make a positive. The 2 stays where it is. The 7 stays where it is. The x and the negative 2 comes down, becomes x to the 2. Here's your 15/4, and I'm just rewriting it as a radical because that's how they had given it to me. Okay? All right, so here's your basic integration rules one more time. Since the derivative of c is 0, the integral of 0 dx is an arbitrary constant c. Since the derivative of k times x, of course, k is a constant, is k, then the integral of k dx is kx plus c. Here you can pull out the constant when you're taking the derivative of a constant times a function. You can do the same thing with integration. If you have a constant, not a variable, but a constant, you can pull it out. As with differentiation, if I have the derivative of the sum or the difference of two functions, I can make that the sum or difference of the derivatives of the two functions. That will also work well with integration. The integral of f of x plus or minus the integral of g of x. As we know, the derivative of x to the n is n times x to the n minus 1. And of course, that's what we've been working on. The integral of x to the n dx is x to the n plus 1 over n plus 1 plus c, as long as n does not equal negative 1. Okay, so now we're going to get into the trig. Since the derivative of sine is cosine, it should make sense to you that the antiderivative of cosine is sine. Since the derivative of cosine is negative sine, it should make sense to you that the integral of sine is negative cosine, because the integral of negative sine would be cosine, and then what they're doing is just pulling that negative out and dividing by negative 1 on the other side. Now I'm going to point out that it's going to be tricky now. You finally got it in your head that the derivative of sine is cos and the derivative of cos is negative sine. Well, now the integral of sine is negative cos and the integral of cos is positive sine. You won't get confused with these if you just keep remembering you're looking for the function whose derivative equals cosine. That is sine x. All right, since the derivative of tan is secant squared, the integral of secant squared is tan, etc. Since the derivative of secant x is secant x tan x, the integral of secant x tan x is secant x. Since the derivative of the cotan x is negative cosecant squared, well then the integral of cosecant squared is negative cotan x. And finally, the derivative of cosecant x is negative cosecant cotan, so the integral of cosecant cotan is negative cosecant x plus c. Okay, so if you know them forwards, it's kind of like if you know that 3 times 5 equals 15, then you know 15 divided by 5 is 3. Okay, something that's very important is the integral of f of x times g of x does not equal the integral of f of x times the integral of g of x. And sadly, unlike differentiation, where when we have a product, we have a rule, we have a product rule, we have no such thing in integration. There is no actual formula. It's a process and we will do it, but it's a formula. Okay, so there is no product rule or quotient rule. So if you do see something like the integral of x times x squared plus 3 dx, you cannot go, oh, I'll just integrate x and multiply that by whatever I get when I integrate x squared plus 3, because you cannot do that. So what you have to do, like we did for differentiation, is expand it for now. So that's going to give x cubed plus 3x. Now you can split up the sum, and now you can, this is what the book does. It goes blah, 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 blah. I would go directly personally from here to here. The integral of x cubed dx is x to the 4th over 4 plus 3 times x squared over 2 plus c, the end. Okay, if you had something like this, number 14 from the book, I would definitely simplify it first. This is 9x squared, and then realize that only this x is squared, so only the x would come to the top. So what happens is I can pull out the 1/9. I'm integrating x to the negative 2 dx. Remember, I'm adding 1 to the exponent and then dividing by that new exponent, and you'll get negative 1 over 9x plus c. Okay. It's just reminding you again, this is called the integrand. This is called the differential of x. You've got to have that there, because remember, the integral of 2 dx is 2x plus c, but the integral of 2 dt is 2t plus c. Okay, again, there's no quotient rule. The integral of f of x divided by g of x is not the integral of f of x divided by the integral of g of x. So just like we did with differentiation, if you have a monomial, split it up. X squared over x to the 4th plus 2x over x to the 4th minus 3 over x to the 4th. Simplify that. That's 1 over x squared, 2 over x cubed, 3 over x to the 4th. Rewrite these with negative exponents, and now you're ready to integrate. Remember, we're adding 1 to the exponent. So we'll get x to the negative 1 over negative 1 plus 2 times x to the negative 2 over negative 2 minus 3 times x to the negative 3 over negative 3, and then we just pretty it up. That's negative 1 over x. That's negative 1 over x squared. That's positive 1 over x cubed. Okay? Now, the other way of doing this is, rather than splitting it up, is you could rewrite this as times x to the negative 4 and then distribute. You'll get the exact same line I just got right here. Okay, in exercise 35 through 44, find the indefinite integral and check the results by differentiation. Okay, as far as check the results by differentiation, yeah, when you have all that time in your life, you just do that little thing. All right, so just a reminder again, because we're going to get into trig here. The integral of cos is sine because the derivative of sine is cos. The integral of sine is cos because the derivative of cos is negative sine. The integral derivative of tan is secant squared, so the integral of secant squared is tan. Here you can pull out a constant. You can break up sums and differences. So here's number 36. T squared minus sine t, so I can split up that difference. Integrate t squared, I get t cubed over 3. And then minus, and the integral of sine is negative cosine, because the derivative of cosine is negative sine. So be careful, that plus or minus is especially going to get you in the multiple choice. Some people have asked me, does it matter whether I write plus c or minus 3 or plus 3c? Keep in mind, c is an arbitrary constant. It really doesn't matter what you write, which is why we keep it as simple as we can. Here's another trig integral, number 38, the integral of theta squared plus secant squared theta d theta. So remember, theta is an actual variable here. So when I integrate theta squared, I'm going to get theta cubed over 3. Remember, the derivative of tan was secant squared, so the antiderivative of secant squared is tan, and then you have your plus c. That's it. Again, there's no product rule, so we're actually going to multiply through, and that works out very nicely for us. Hopefully you know a function whose derivative is secant tan. That function is secant. Hopefully you know a function whose derivative of secant squared, and that function is tan. And there's your answer. It's not very difficult.